Okay, so what do we reckon? There's 15 members, and we've got 3 positions to choose. How are we going to do this? How many different ways are there to order, or how many permutations are there to choose 3 people from a group of 15? How many ways can we order 3 people from a group of 15? What do you reckon?
So for the first slot, we have 15 options, so that means 15 factorial.
Right.
And then when we choose the vice president, the second slot, it will be 14.
Yep.
And then 13.
Good, okay, good. So, and you're happy you're just going to multiply these numbers together. So what you've literally done here, you remember when we had those 3 positions to fill up there, right? And I just had 3 people to choose from. It's exactly the same idea. But this time imagine there's 15 people. I mean, there's about 15 people in here, slightly more. About 15 people here. So I'm just going to choose someone to put in that first position. There's 15 people to choose from. Does that make sense? Yeah? Then we choose someone to go there. So how many people are left to choose from to put in the second position? 14. And then we put someone in there. So how many people are left to choose from to put in that third position? 13. Okay? So you just multiply all of these things together. Okay? And you can see that illustration on the board there. So 15 people. Choose 15 people to go from there. Then 14 people left to choose from to go there. And 13 left to choose from to go there. All right? So it's going to be 15 times 14 times 13, which is 2,730. Now, here is my question to you. This thing, 15 times 14 times 13, it's not quite a permutation, is it? It's not quite a factorial, is it? So it's not quite 15 factorial, is it? Because 15 factorial will be 15, in fact I can write it out, be 15 by 14 by 13 by 12, etc. Two times 1. Okay, so 15 factorial would look like this. So 15 multiplied by successive numbers all the way down to 1. This isn't quite that, is it? What are we missing? Good. So in other words, we just want this bit. We don't want the 12 right the way through to 1. Okay? So in other words, we've got the 15 factorial, and we're going to get rid of that 12 factorial. Yeah? The easiest way of getting rid of it is by dividing by that 12 factorial. Now here's my question. Where does that 12 factorial come from? So the 15 factorial comes from the 15 members. Okay? 15 factorial comes from the 15 members. Okay? But then we're choosing 3 of those members. So where does this 12 come from? Minus? Good. So in other words, we need to divide by 15 minus 3 factorial. This is the bit we want to get rid of. It's like the leftovers. Yeah? The leftover people that haven't been chosen. 15 minus 3 factorial. Yeah? So in other words, if you want to order 15 people and you only want to choose 3 of them, you can say that it's 15 factorial divided by 15 minus 3 factorial. Or in general, if you have n people and you want to order them, so you want to permute them, order them, such that you only want to order r of them, so 3 or 4 or 5, okay? So you have n people and you only want to order r of them, the rest of them you don't care about. You can say, using this idea, it's going to be n factorial, that's the number of different ways of ordering those n people, divided by n minus r factorial. That's the leftovers. Those are the people that aren't chosen. Does that make sense? Yeah? So these are the leftovers. So if you have n people, but you only want to order r of them, this is how you would do it. Does that make sense to everyone? So what we're now going to do is consider the situation where we don't care about order anymore. So we just care about choosing objects, but we don't care about ordering them into, say, a line. Okay? So let's suppose, for example, that we have 5 members in a class. Okay? So we have 5 members. And all we are going to do is choose 3 of them. Now, choose just means we don't care about ordering them. We just care about choosing them from that and then just keeping them on one side. Okay? So we don't care about ordering them in a line or anything like that. We're just simply going to select those three things, okay? So how could we do that? Well, look, we could think about it as an ordering. So in other words, there's three different positions which we could put these three members in which case, are you happy it's just going to be the same as before? 5 times 4 times 3, okay? Or we could write that as 5 factorial over 5 minus 3 factorial, okay? However, this would be the case when we're ordering. We don't care about orders anymore. So let's suppose we put A in this position, B in this position, and C in this position. So person A, person B, person C. Are you happy that if I put C in this position, A in this position, and B in this position, this would be the same situation because now all I care about is choosing them. I don't care about the order. So if you like, to get rid of all those different orderings, what am I going to have to divide by? 3 factorial. Because I don't care about all these different orders of these three people anymore. I just care about choosing them. I don't care about ordering them, okay? So in which case, this is how we would do it. So in general, there's a distinction between a permutation, which is an order, and a combination, which is just simply choosing or selecting the objects, okay? So if I want to change this to a choose situation, let me do it in blue, okay? It would be n objects that I'm choosing from, so 5 members in a class, and I just choose those R people, so in this case 3 people, okay? And all it is it's just that divided by R factorial, so it's divided by that 3 factorial for all those different arrangements. So it's just going to be n factorial over n minus R factorial, same as before, however I'm also going to have to divide by R factorial because I don't care about all these different arrangements, they're all the same to me. So to me, all of those orderings would be the same. I just care about choosing them. I don't care about ordering them anymore. Hence why I have to divide by that R factorial. That counts for all of the different orders, and I don't care about them. All right? So that's a kind of distinction between them. Now, this here is called a combination. It's really important. We will meet it again. There's 2 different notations. You can either write it as that, or if you prefer, you can write it as this. So n choose R, n choose R. Okay, they're both exactly the same thing. And I put both of those on the same screen. But if you like, the only difference between this and this is just dividing this by R factorial. And you can see that on the screen there. Does that make sense to everyone?